Hello, good evening, everyone. I hope I'm audible. I welcome you all to the GRE Preparation Made Easy Quantitative Reasoning class by Mrs. Annapurna Murugan. Here are a few instructions for the participants. Make sure you have a stable internet connection and noise-free environment. We recommend you to use your earphones for the best experience. Also, please respect your instructor and your classmates. Don't write anything inappropriate on the chat box. Also, how to answer the polls, you have to click on the More button and where you can see activities and you will be headed towards polls. Also, we have three packages, that is bronze, silver, and gold. I'll be providing with a coupon code to upgrade from basic to bronze package. Also, if you want to upgrade to silver and gold, you can. You'll get extra benefits like expert university recommendations, dedicated counsel for the entire application process, and so on. We are also providing free profile evaluation with our experts. It includes comprehensive evaluation, university shortlisting, course recommendations, recommendation reports, and doubt clearance. You can register through our website and it is free of cost. Also, we conduct live IELTS classes Monday to Friday, 7:30 to 8:30 p.m. and Duolingo classes Monday to Friday, 6:30 to 7:30 p.m. You can register for free. Also, we have this Ubergrad webinar on Saturday, 16 December, 7 p.m. to 8 p.m. It is how to score 7.5 plus in IELTS. It includes the exam pattern, how to prepare, and time management hacks, and so on. We also have one-on-one IELTS classes for just rupees 5,999. It includes 20 hours live classes, class recordings, daily class worksheets, 10 sectional tests, and 5 full-length mocks. Here are a few achievements. This is the Ubergrad website. You can select the country, your course, and specialization. When you go and explore, we have countries, universities, courses, and exams. You can get all the information from here. When you go on solution, we have test preparation, additional services are provided. Also weekly blogs are uploaded. When you go on free profile evaluation, you can book an expert slot, select the timings, and it's free of cost. Also, when you go here on my test preparation and click on view course, you are headed towards the recordings and handouts. So in case you've missed any classes, you can go through the handouts and recordings. Any other doubt you can ask at the end of the session. Thank you. Also, I'll be sharing the links so you can go through the chat box.
Hi guys, good evening. I hope everyone is doing good. Yes, today we are going to discuss about one more DI based topic, that is probability. Okay, so I'll be presenting screen before I would start the session. Here we go. Just give me 1 second. So I guess everyone knows about probability. What is this probability? The chances. Okay. So what is the chance of anything that would occur or not occur? So that's called probability. And it is in fact one of the easy topic in the entire mathematics, and this probability comes under your special mathematics. Okay, when you talk about special mathematics, you have probability, you have permutation, combinations. So all these things comes under this matrices, all these things comes under the special mathematics. But probability is one of the thing which is almost asked in in all the competitive exams. Okay, so and what is this probability? We usually say, right, whether you will be attending to tomorrow's party, we say probably I may or I may not. May and may not is a probable thing. So that means what? So it basically gives us that unpredicted result. Okay, what is this probability? Probability is nothing but of an event. It says how sure, how certain the event can happen and how uncertain the event will not happen. So this thing we call it as probable. That means where we are not sure about the things which will happen here. So basically, let me tell what is this probability. So we are talking today about probability. So what exactly this thing means? It is a branch of mathematics that calculate the likelihood of an event that of an event's occurrence. Okay, whether that event's occurrence and what's the possibility of its occurrence. So that we call it as probability. See, in probability, the thing is that we come across few terminologies which you people need to know. Okay, so first thing is random experiment. We come across this word very often when you get problems on probability. What is this random experiment? Random experiment is nothing but it is the process or it is the do which happens where you can't predict, you cannot predict what will be the result. Okay, so when you can't predict the result of some outcome or some experiment or some action, basically I can use the right thing as action, when you are not able to decide or detect the result of some kind of occurrence or some kind of happening, then we call that as random experiment. Example of this random experiment, in fact everything is random experiment only if we take. So when you toss a coin, can you predict whether you will be getting, can you surely say, not predicting, predicting we can do, but when you can you say surely that you will be getting so tail only, head only? No, isn't it? When you dice, when you throw a dice also, whether you will be sure that you will be getting 6 or 0 or whatever it is? No, right? So that means these experiments, these, what is that occurrence, we call them as what? Random. Why? We are not sure. Random. It can happen, it may not happen. It will always have two things. Okay. So one, it may be something, it may not be that particular thing. So that is our thing. So example, tossing coin, throwing a dice, and even selecting a card from the deck of cards, or selecting any object. It could be anything. Even the results of our test also is what? So an random experiment. Okay. Now, so event we call. What is this event? The outcome associated with an experiment, the outcome that is associated with an experiment that we do, with the action that we do, it is called as what? Event. Okay, that means when I toss a coin, when I get head, okay, that is an event. When I get a tail, that is an event. Okay, so these thing, event, you need to know what is this event. Event is nothing but it is the outcome that is associated with an experiment. Okay, so that's the event we have. Now, on the basis of event, let us understand some of the important things here. Events what? If events probability is 1, probability is 1, what do we call that as? Sure or so certain event. That means we know that that event will occur. Okay, that's your sure or certain event. If the probability of an event is certain, we know that it will happen, so then the probability is considered to be 1. Okay, so probability. So if the probability is 0, then we call that event is impossible. So what is that? If the probability is 0, if the probability is 1, so that means that event can happen. So when we toss, what is that? When we roll a dice, if I say, so the event where we need to get 7, do you think that 7 can appear? Because in a dice, we'll be having only 1 to 6 But if I say, no, the event where we are going to get 7 when we roll a dice, that means that event will not happen only. So that means it is an impossible event. Why? So that thing will never happen. So it is an impossible event, and the probability of such event will be what? So it will be 0 here. Okay. And next. So an event with only one possible outcome. So that is called as elementary events. Okay. So these are the things that we basically have. Now let us try to talk about probability, and then we'll be discussing, we'll be doing few problems on the basis of this. Probability or is basically what? It lies between 0 to 1. What is this probability? Always remember that probability should lie between 0 to 1. Whatever the possible events, see, when I toss a coin, basically what? Either I get 8 or 10. So what are the chances? So chances, total events, what we have? 2. Out of this, getting 1 is 1. Okay. The probability of getting head is what? 1 by 2. The probability of getting tail is also 1 by 2. I have one chance of getting tail. So therefore, what happens? Now see, the probability of these both events which happen when we toss a coin should give rise to 1. But individual events should be always less than 1. Remember. So the total events probability, that means what? When you sum up the probabilities of the total events of the experiment, that should give you one value only. For example, you can see half plus half, it is what? 1 year. Isn't it? So remember that. So when you take that, this one, what is that? The deck of cards, there also you take different combination of events. The sum of all the events associated with the card, okay, should sum up to what? 1. What it should sum up to? It should sum up to 1. That is the entire this one. So the sum of the probabilities of all the elementary events of an experiment is 1 year. Okay. Now, I will be talking about one more thing, that is the complementary. So that means the probability where we are talking about the complement of an event. Complement of an event. What is this complement of an event? So it is nothing but. So say we have a possible event, and one impossible event we get. Or not impossible. I can say the opposite of it. For example, when I roll a dice, roll a dice, okay, probability of getting 1. Okay, probability of getting 1 is 1 by 6. This is event. Okay, this is event. Now the event, this event sum. So complement is what? The probability of not getting 1. Not getting 1 is called the complementary. The probability of not getting 1 is what? 5 by 6 here. Okay, the probability of not getting 1. So that means the complementary of the event is 5 by 6. See, when you write event plus, so its complement, it should give 1. So that means what? So you can see 1 by 6 plus 5 by 6. So will be always 1. Getting it? This is nothing. E complement is what? The event where that E should not occur. Okay. So what we can say? The event, so where that E should not occur. Okay. That is the thing we basically have here. Now, I have 2 more properties that I would like to speak about here. If we have A and B, 2 possible outcomes, 2 possible outcomes of an event. Okay, it is the two possible outcomes of an event. Now, if we have, if the probability of A is greater than probability of B, what does this mean? What does this imply? This implies that event A is more likely to occur, more likely to occur. That means more frequently to occur than event B. Okay? So what is P of A greater than P of B? Event A is more likely to occur than event B. Then if P of A is equals to P of B, that means what? They both are equally like head and tail. Okay. In that case, what happens? They are equally likely to occur. Both has that chances. Both has equal chances of occurrence. Okay. So that's equally likely to occur. Okay. So that's the thing we basically have. And now I'll just give one quick information about your cards. Okay. So in cards, what happens? Basically, 52 cards will have. These 52 cards are differentiated into 4 groups, okay, of 13 cards. 13, 13, 13. So one, we can say that spade, club, heart, and diamonds. Heart and diamonds. In each of them, 3 face cards will be having. In each suit, we call it as suit. Okay. Into 4 suits will be having 13, 13 cards. So 3 face cards in each suit will be there. Which are those face cards? King, queen, then jack. Okay. And ace is number 1. Okay. Then from 2 to 9 will be having the things. Okay. This is how it will be going here with us. Okay. And now in this also we have two sets black cards and 2 sets red cards. Okay. So black cards are which one? Your spades and clubs are black. And red cards, which one? Hearts and diamonds are red cards. Remember this. These information should be very important. Why? Because when they give the problems on these cards and all, so you should know this. Without the knowledge of this, you will not be able to get. So now let me do the questions for you guys. The first question, find the probability. Find the probability of getting a black queen. See, black queen when a card is drawn at random from a well shuffled card, from a well shuffled pack of 52 cards. Okay. So what is that? You need to find the probability of getting a black queen. So when a card is drawn at random from a well shuffled pack, this one pack of. So what is the total number of, and what is probability of an event? Probability of an event is equals to total outcomes by events outcome. Events outcome. Okay. So your total, how many cards we have? 52 cards. Out of that, so how many how many suits of black cards we have? 2 suits. In 2 suits, how many face cards we have? 3 and 3, 6. In that, how many your queen will be there? In each suit, 1 queen. That means we have 2 black queens here. So therefore, probability of that event will be what? 2 divided by 52. That is 2, 2 2s are 4 and 2 6. So that is 1 by 26 is your probability. See, that's the reason I said we need to know the colors, we need to know this one of those events. So then only it will be getting what is that, you can understand that particular thing. Now, I'll give one more question here. A letter of English alphabet is chosen at random, is chosen at random. What is the probability? What is the probability of choosing a consonant? What we say, of choosing a consonant. We need to prove that. So what is the probability of choosing consonant? How many totally? How many we have? 26. In that, so do you guys know English alphabets? So is classified into consonants and your vowels. So vowels, how many we have? A, E, I, O, U. So that means they are saying, so we are choosing only consonant. If we are choosing consonant, out of 26, we have what? So 5, your this one. So we are left with 21. We have 21 consonants. When we pick, we may get any, what is that? Any of these 21 consonants. So therefore, probability is what? 21 by 26. Now, you should put it in simpler form, but we don't have this simpler thing. Why? Because they don't have any, this one, what is that? Co-prime numbers. Therefore, it will be what? 21 by 6 only. What we can say? It will be 21 by 6 only. Here we have. Getting it? So now, let me take one more example. A die. Don't expect that in our probability will be only getting what? A dice problem, or will be having only coins problem, or will be having only from your alphabets, or this one, what is that, I can say, your cards problem. No, we'll be having on different things also probabilities. Okay, so kindly understand the concept here. That's it. A dice when thrown once. And also one more thing, guys, they usually, what is that, use this, the fair coin, so the fair dice and all. That is to show that dice or thing is not tempered to get only one values. Okay, so that is the thing. So therefore don't get confused about that. What is the probability of an event getting prime number? Prime number. Okay. So here, what is that? A dice is thrown. So dice is thrown means in dice we have 6 faces, which are those 1, 2, 3, 4, 5, and 6. Out of this, what? We need to get prime numbers. What are prime numbers? 2, 3, sorry, and 5. So prime numbers, how many we have? 2, 3, and 5. That is 3 prime numbers we have. And what is the total numbers? We have 6. So 3 by 6, which is half. That means the probability of getting prime number is what? So 1 by 2. And so if we say in this further, if they say probability of getting even prime number, now even prime number, do you think it will be same? Which is the even prime number? Only 1 near. So that means what? So it has to be what? So 1 divided by 6. See, this is for normal prime number. But if they say, so even prime number, it should be 1 by 6. If they say odd prime numbers, we have 3 and 5. So therefore 2 by 6, that is 1. So 1/3 of the event here. Okay. So getting it? I guess you people are getting these things. These are very simple concepts, guys. So now let me give you little different question. If a number is chosen, if a number x, let me take, if a number x is chosen at random. So what we are doing, we are choosing a number x random from the numbers -3, -2, -1, 0, 1, 2, and 3. Find the probability of x square less than 4. That means we need to take x square value, but it has to be less than 1. So what we should do here? So let us frame a table. Now we need to pick the values in such a way that we should get that x square should be less than 1. What are the different x values they have given? X and x square. If x is -3, x square is 9. If x is -2, x square is 4. If x is -1, x square is 1. So if x is 0, so 0 square is also 1. 1, 1, 2, 4, 3, 9 we have. But what we need to have? We need to have the values of x square less than 4. So less than 4 where we have these three. Okay. So now, how many numbers we have here totally? For how many x values we have? 3, 7. Out of 7, so how many values of x will give us x square, which is less than 4? It is 3. So therefore, the probability of that particular event is given by 3 by 7. Now you should not get confused only. You just put the table like this, and then you people, in fact, the table is not required. But however, you not to get confused, you people can use this particular thing. Okay. And the next question. A dice is thrown. A dice is thrown once. Okay, what is happening? A dice is thrown once. What is the probability? Oh, we have done this. Probability of getting. So a prime number we have done. So let us do one thing. If a dice is thrown once, probability of getting composite numbers. Composite numbers. Okay, that means I'm not talking about prime. So when I throw a dice, I'll be getting either 1, 2, 3, 4, 5, 6. Isn't it? We'll be either getting 1, 2, 3, 4, 5, 6. In this what? Prime numbers, so we know 2, 3, 5. We don't want this. And we need to get composite number. Remember, 1 is not a composite number. Okay, so 1 is not a composite number, so that 1 also goes out. That means what? What are the composite numbers that we have? Either we'll be having 4 or 6. So what we'll be having? 4 or 6 will be getting. That means we have 2 events where we can get the composite. So out of 6 outcomes, 2 outcomes can be composite. So therefore 2 by 6 probability, but in its simplest form, you can write 1 by 3. Say, in this, finding probability is not difficult. Only the thing is you need to be clear with certain terminologies, certain things you people need to be clear with. That is the thing that you people focus on. Now, let me take one more question here. A number is chosen. Number is chosen at random. Okay, what happens? You see that a number is chosen random from the numbers. Here we have, what is that? the numbers. What are those numbers? -5, -4, -3, -2, -1, 0, 1, 2, 3, 4, 5. Find the probability of that the square of the number should be less than or equal to 1. What is that we have? So when you do the, what is the event here? So the probability of when you square this number, it should be either less than or equal to 1. We all know that this will be what? 25 square 16, 9, 4, 1, 0, 1, 4, 9, 16, 25. They're asking the probability of getting x square less than or equal to 1. 0 is less than. If you take -1, you will get 1 and 1. So that means 3 outcomes we have. But how many total we have? 5 and 5, 11. So out of 11, we have 3 outcomes that satisfies the question here. What is that? You will be having 3 outcomes that satisfies this question, and hence, so 3 by 11 is your this one. Okay. And next, here again, a child has a dice whose 6 faces show the following letters. Now we are not taking this one. What is that? The numbers. But the 6 faces as what? A, B, C, D, E, and A. That means what? We have double it. The probability of getting A and probability of getting D. Out of 6, how many faces are A? 2. So the probability is 1 by 3. For D, it is 1 by 6. Why? Because only one D is there. So we can take it as 1 by 6. Okay? Any doubts on these, guys? Now, let us do few marble problems here so that you can just, because marble problems will be getting usually. Yeah. The question is little big. The probability of selecting a blue marble at random from a jar that contains only blue, black, and green marbles, is 1 by 5. The probability of selecting a black marble is from the same jar. Is 1 by 4. Okay. If the jar contains 11 green marbles, find the total number of marbles in jar. That's what I said, na? So here, like, see, just probability and this one only, but little complicated way we are having here. Okay. The probability of selecting a blue marble at random from a jar which contains 3 colors is 1 by 5. At the same time, the probability of black marble is also 1 by 4. If the jar contains 11 green marbles, find the total number of, you need to find the number of marbles. So I'll explain here. How many green marbles, number of green marbles, 11 we have. So probability of blue is how much? 1 by 5. Na? Probability of blue is 1 by 5. Probability of black is how much? 1 by 4 we have. But we don't know the number of blue and this one. So what we'll say, number of blue, let us take it as X, number of black. Okay, let us take it as Y. So therefore, what we need to find out, we need to find X plus Y plus 11. How much here? Okay, we all know what the probability of all the event is 1. 1 will be what? Probability of black, probability of blue, then probability of green. Okay, together it is. What is probability of this one? Blue, it is 1 by 5. Probability of this one, 1 by 4. And probability of green, so we don't know. Let us take it as Z. Okay, will be equal to 1. So therefore, what you can do? 1 minus, find the LCM. So 20, this will be 4 times and this will be 5. So that is minus 1. So when you take it, it will be 1 by 20. Okay, is equals to this one. So you are going to get, what is that? The probability of that. The probability of that gives us the green here. Equate it. Equate it, guys. Just give me 1 second. So what is that we have? We'll be having 1 minus. So 20. So here also, you see, like this also becomes what? 20 Z here by 20. Okay. So it becomes 1 by 4. So plus 5. Or we'll do like this. We'll take it in this way only. Let us not take the probability, because little more complicated it will become. Let me do in this way. We take this numbers only. So what we'll do, so the probability of black is what? 1 by 4. Na? So how we get probability of black? So we know the number of black is Y. So Y divided by X plus Y plus 11 is equals to 1 by 4. This implies what? 4y is equals to, what is that? We'll be taking x plus y plus 11, cross multiply. So this implies x minus 3y plus 11 is equals to 0. Let us take this as equation 1. What we are doing? X minus 3y plus 11 is equals to 0, which implies x will be equal to 3y minus 11. I can take it like this. Okay. Now, the probability of x will be given as what? Which is nothing but x divided by x plus y plus 11. That is equals to 1 by 5. Again, this goes like what? 5x. So, is equals to x plus y plus 11. So you can substitute here this one. So 4x is equals to y plus 11. So that means equate both of them. If x is equals to 3y minus 11, substitute. 4, what we can do? 4x is equals to, or you consider y plus 11, y plus 11, and the other equation is x is equals to 3y minus 11. Minus 11. You can either use the elimination method, substitution method. So you can use it and this one, substitute in the place of this one. What is that? So this one, it's better like 4x minus y is equals to minus 11, x minus 3y is equals to positive 11. But what one of the thing you eliminate, so what I'll do, I'll cross multiply into 1 and 4. So you will be getting 4x minus 3y is equals to minus 11, and 4x minus 12y is equals to 44 here. You will be getting, you cancel it out, minus, plus, minus. This gets cancelled. You will be getting 12 minus 3 is 9. 9y is equals to how much you are getting? Minus and minus plus. So minus minus you need to add. So 55 you are going to get. So y will be equal to how much? Somewhere we have gone wrong here. What is that? 4, 1, 4, 4, 8. Just give me 1 second. Y is equals to 55 by 9. Now we need to get the perfect numbers, or we do one thing, 3y, and if I take 4x minus 12y, let me take this. It becomes 4x minus y is equals to minus 11. So if I take x minus, oh, yeah, we did a mistake. It should be minus 11 only. Why? Because only this we are shifting. So yes, cross multiply 1 into 4, same you will be getting 4x minus y is equals to minus 11, and your 4x, so minus 12y is equals to minus 44. But now it becomes what? Minus plus, so and plus. So it becomes, so what is that? This is 1, right? So 1y, 1 and 4. 11y, positive 11y is equals to 33. So y is equals to 3 we are going to get. Is it so? Plus, what is happening? Just give me 4y minus y 11, 1x and 3y is equals to minus 1 and 4. 4x minus y minus 11, 4x. So minus 12, y is equals to minus 44. Perfect. So minus, plus, and this one. So plus we are going to get. It gets cancelled. So minus 1y and it's equals to 33. Yes. So now same value, substitute in x, you are going to get the x value. Then you will be getting the total number of marbles here. Okay, so what is that? If y is equals to 33 by 11, so 3 we are getting. So you can substitute in the place of x. X is equals to minus 2. Somewhere we have gone wrong. Let me see the equation. X is equals to 3y minus 11 and 4x is equals to y plus 11. If I take, let me, x minus 3y is equals to minus 11, and the other one, 4x minus y is equals to plus 11. Okay. If I use the substitution method, x is equals to 3y and y is equals to this. Okay, guys, it's a simple calculation. Just check it out. Okay, somewhere we have missed on the thing. So you will be getting what x is equals to 3, but here we are getting what is that? So if I substitute 4x is equals to 3 plus 11. So you'll be getting x. So 14 by 4. No, we can't get the decimal here. So let me take this equation again. What was the equation we had got? One was y by x plus y plus 11 is equals to 1 by 4. This implies 4y is equals to x plus y plus 11, which implies x plus 3y minus 3y plus 11 is equals to 0. The other equation is x divided by x plus y plus 11 is equals to 1 by 5 we had. So this implies 5x is equals to x plus y plus 11. So this goes like, let us shift these things here. 4x minus y minus 11 is equals to 0. Let us try to equate this. 4x minus y minus 11 is equals to 0. X minus 3y plus 11 is equals to 0. Yeah, somewhere this. Now you're 1 and this is 4. So you end up getting 4x minus 1y minus 11 and 4x minus 12 y plus 44. So if you do this minus plus minus, this gets cancelled. Yeah. So you will be getting 11y. So minus 55. Okay. So you will be getting 11y is equals to positive 55. Y is equals to 55 by 11, which is nothing but y is equals to 5. So now substitute anywhere in any equation 5. So therefore x minus 3y plus 11 is equals to 0. So now x minus 3 times 5 is minus 15 plus 11 is equals to 0. That is x minus 4 is equals to 0. X is equals to 4 we get. So therefore total number of marbles will be what? 5 plus 4 plus and how many green? 11. So it is 20 marbles we got. Somewhere equation we had just missed here. So therefore this is the thing. So totally how many marbles we have? We have 20 marbles in this particular case. Okay. Got this thing? Just have a look. We missed something in the previous question because of that jumbling things. Okay. Now, next one more question. Let us do. We have an integer is drawn at random. An integer is drawn between 70 and 100. Okay. Find the probability. You need to find the probability. So probability where it is a prime number. Probability that it should be a prime number. Another one is what? Divisible by 7. Divisible by 7. Okay. So now, what is that we can do? Prime number. Prime number, yes, you need to know. What are the prime numbers between 70 and 100 if you take? 71 is a prime number. 73 is a prime number. 79 is a prime number. Then when it comes to 80, so 83 is a prime number. Then if you take 87 or 77, No, 87 is not a prime number. 89 is a prime number. Then if you take 91, so 91, 7, 7. No, it is divisible by 7. So therefore, 91 is not prime number. 93 also no. So then if you see 97, yes, it is prime number. So how many prime numbers we have? 1, 2, 3, 4, 5, 6. So 6 prime numbers we have between 70 and 100. So how many numbers are there? The total outcomes. If you see, it will be between they are asking. Between means extremes you need to leave off. It is not 30. So it should be 29. So this is also one thing. Students will take it as 30. It is not 30. It is 29. So therefore, in this case, so the probability is what? 6, this one, 6 by 29. What is the probability we have? You see that it will be 6 by 29. Okay. So 6 by 29 is the probability here. While, so when you take, so the other thing is what? Between 70 and 100. Okay, the multiple divisible by 7. So take out, what is this one? 720 is a 140 we have. So 70 15s you check out how much it is. Just give me 1 second, my pen. So basically, if you see the 7, like this one, the first number is 7 11s are 77. 77 is one number. And then 84 is another number. 91 is another number. And 98 is another number, which is divisible by 7 between 70 and 40. This one, 100. So that means how many numbers are there? Basically, we have, so 4 numbers that are divisible by 7 here. So therefore, 4 out of 29. So the probability is what? 4 by 29 is the probability that we basically have. I hope you people understood these things, how to find the probability here. Any doubts that you people have? Ravinder, yeah, it was correct. So mine, I had messed with a lot of calculations. So because of which, yes, Ravinder, it is correct. Y is 5. Right. Any other queries, guys, you have? Okay. Okay, then, guys, I hope you guys understood how to work on these things. So, yes, so we'll be meeting you guys in the next class. Bye until then. Take care.
Thank you, ma'am. Also, if anyone has any doubt related to the Ubergrad website, you may ask now. Otherwise, I'll be ending the session. Thank you.